Ever boarded a flight and thought, what if something goes wrong up there?
Hmm.
It's a question that crossed a lot of minds on Delta Flight 1203.
Oh, yeah.
Imagine this. You're taking off from Salt Lake City,
All right.
cruising at 30,000 feet,
Yeah.
when suddenly that familiar ear-popping sensation turns into intense pain.
Oh, wow.
People are clutching their ears, some even experiencing nosebleeds.
Oh, no.
That's the scene passengers found themselves in aboard Delta Flight 1203, a Boeing 737-900, just 23 minutes after takeoff.
Wow.
Initial reports painted a pretty harrowing picture. Intense ear pain, bloody noses, and to top it off, the oxygen masks didn't deploy. So today, we're going deep on this incident, but we're not just looking at what went wrong. We're going to use this as a launch pad to understand the intricate systems that keep us safe at 30,000 feet, and how incidents like this, while scary, actually contribute to making aviation safer for everyone. Let's rewind those 23 minutes and break down what those passengers experienced. I've always wondered, what happens when cabin pressurization fails mid-flight?
Well, it's all about, replicating the atmospheric conditions that our bodies are used to.
At sea level.
So at 30,000 feet, the air outside is much thinner with significantly lower oxygen levels.
Right.
Without that pressurization, our bodies would be working overtime to get the oxygen we need.
Right.
And we'd experience something akin to what mountain climbers face at high altitudes, hypoxia.
Hypoxia, that sounds serious. Could you elaborate on that a bit more?
Sure. In simple terms, hypoxia means your body isn't getting enough oxygen. Now, a mild case might leave you feeling a little lightheaded or dizzy, but as it gets more severe, you could experience confusion, impaired judgment, even unconsciousness.
Mm-hmm.
Not exactly what you want when you're hurtling through the air in a metal tube.
Right. Definitely not ideal. And this incident really highlights how crucial cabin pressurization is for a safe flight. But if the pressurization failed so drastically, why didn't the oxygen masks deploy? You'd think that'd be a given in a situation like this.
Right, you'd think so, wouldn't you?
Yeah.
It all comes down to specific thresholds built into the system.
Yeah.
The oxygen masks are designed to deploy automatically when the cabin pressure drops below a certain level.
Okay.
Think of it like a safety valve.
Mm-hmm.
Now, while those on board Delta 1203 were undoubtedly uncomfortable, it seems the pressure didn't quite reach that critical point to trigger masks.
So it wasn't a malfunction, but rather a matter of the pressure not dropping low enough to activate the system.
Precisely. And this actually highlights a fascinating aspect of aircraft design, the concept of redundancy. It's like having a backup plan for your backup plan.
Okay, let's unpack this idea of redundancy a bit. It sounds crucial, but I imagine building in all these backup systems must factor into the economics of air travel.
You've hit on a crucial point. You see, there's this delicate balance between ensuring safety and managing the complexities and costs associated with it.
That makes a lot of sense. But before we delve further into those complexities, let's circle back to those 23 minutes and those terrified passengers. If the masks didn't deploy, what ultimately brought them back to safety? What mechanisms are in place to handle a situation like this?
It's remarkable how many layers of safety are built into modern aircraft.
It's like those Russian nesting dolls.
Yeah.
Layers upon layers of safety mechanisms.
Exactly. Let's start with the foundation. Rigorous maintenance.
Okay.
We're talking about meticulous inspections of every system,
Right, yeah.
but especially the pressurization system.
Okay.
The outflow valves, the air pumps, these components undergo constant scrutiny to ensure they're in peak condition.
So it's not just a quick once-over.
Oh, no.
They really go deep into the guts of the plane.
Absolutely. These planes are put through the ringer, and for good reason. And it's not just about visual checks either. Sophisticated monitoring systems are constantly at work,
Right.
measuring cabin pressure, analyzing data,
Okay.
and making real-time adjustments.
Okay, so if there's even a slight deviation, these systems can automatically compensate. It's
Okay.
like the plane has its own immune system constantly adapting and reacting.
That's a great analogy. And remember that redundancy we talked about?
Yeah.
It plays a crucial role here.
Okay.
Take the pressurization system, for example. It's designed with multiple backups. If one component fails,
Right.
another is ready to kick in.
It's both reassuring and a little mind-boggling to think about. We board these planes trusting that everything will work perfectly, and this intricate web of engineering and human ingenuity makes it possible.
It's a testament to how seriously aviation safety is taken. And it's not just about protecting lives. It's about maintaining public trust in air travel.
That's a really important point because one high-profile incident can have ripple effects throughout the entire industry.
Precisely. But it's also important to remember that safety isn't solely the responsibility of engineers and airlines.
Okay.
Passengers have a role to play as well.
Oh, this is where I confess I usually tune out the safety demonstration.
You're not alone. But seriously, understanding things like barotrauma, that ear pain we talked about, and knowing what to do if those oxygen masks do deploy can make a difference.
So maybe paying attention to those safety cards isn't such a bad idea after all.
Right?
It's about being informed and prepared, even if those worst-case scenarios are unlikely.
Exactly. It's about being an active participant in your own safety. Now, with all this talk about what's happened in the past and how planes are designed, I'm curious to circle back to the Delta 1203 incident. This was a near miss, but what's the situation now?
Right. What happened after those passengers made it safely back to the ground? So what became of that Boeing 737 after this harrowing incident? Did they just scrap the whole thing?
You might be surprised to learn that the aircraft was back in service relatively quickly.
Really? I have to admit, that's kind of wild to think about. Like, nothing to see here, folks. Back to your regularly scheduled programming.
Well, not quite that simple. While the plane itself was repaired and cleared to fly, the incident triggered a thorough investigation by the FAA.
Makes sense. They can't just have planes dropping out of the sky because of pressurization problems.
Exactly. The FAA takes these incidents very seriously. They'd be looking into everything, the plane's maintenance records, the pilot's actions, the data from those black boxes we always hear about,
Yeah.
all to pinpoint the root cause of the pressurization failure.
So this wasn't just about slapping a Band-Aid on the problem and calling it a day. They were looking for systemic issues that might need addressing.
Absolutely. And this is where things get really interesting. Every incident, even a near miss like this, provides valuable data.
Data, like this one incident becomes part of some massive aviation safety database.
Exactly. Think about it. Every time a sensor picks up a fluctuation, every time a pilot has to make a split-second decision, it's generating information. And by analyzing this mountain of data, patterns emerge, vulnerabilities are exposed, and ultimately safety protocols are refined.
That's incredible. So in a way, Delta Flight 1203, as scary as it was for those on board, might actually contribute to making flying safer for all of us in the long run.
Precisely. Each incident, each close call, adds another layer of understanding. It's a continuous feedback loop, a constant striving for improvement.
It makes you realize that the incredible safety record of modern aviation isn't just a happy accident, it's the result of meticulous data collection, rigorous analysis, and a relentless pursuit of making things safer.
And it's a testament to the collaboration between engineers, pilots, air traffic controllers, and countless others working behind the scenes. They're all part of this ongoing quest to make air travel as safe as humanly possible.
It's a humbling thought. The next time I find myself nervously eyeing the turbulence or fidgeting during takeoff, I'll try to remember the incredible amount of effort and ingenuity that goes into getting us from point A to point B safely.
It's something we often take for granted. But that smooth flight, that uneventful landing, it's a symphony of technology and human expertise working in perfect harmony.
Well said. And on that note, we've reached the end of our deep dive into the world of aviation safety. Until next time, may your flights be smooth, your landings gentle, and your appreciation for the marvels of aviation soar to new heights. Thanks for listening.